always keep your time on time because I say the correct time is 10 minutes. So please come back in 10 minutes. Okay, so everyone knows, so our final break time is 10 minutes. So I would like to announce the second stage. The first stage is the opponent challenge the recorder, please.
We would like to challenge your partner number 14 water bottle rocket.
What's that?
So each rider have to write down their names on the blackboard. Okay, this is the Chinese presentation of the whole study.
Hello everyone, I'm Ryan from TYPT, and today I'm going to introduce the problem number 6, water bubble rocket. So this is the problem statement. Our main focus is about the relationship between pressure and water amount when we are calculating the acceleration. And in the problem statement, we mainly focus on the partially filled with water and other certain conditions. This is our presentation outline. This is the observation. So as you can see, after pumping water into the rocket and using the starting device to release the rocket, and it will burst into the air. This is my first theory, continuity equation. The continuity equation is a theory used to explain an incompressible fluid while it runs through different areas. So in the equation, area 1 times velocity 1 equals area 2 times velocity 2. And this can explain when the fluids fly through different areas. The second theory is Bernoulli's law, and this is used to explain the later equation I'm going to be calculating. So this is the formula derivation. By using the first equation and the second equation, we can calculate, we can analyze into this, and we can get that the velocity of the fluid flying out the bottle will be this, and this will be used in later on. This is the third theory, is the conservation of momentum. So this theory is used to explain that the momentum will be conserved while this fluid is having a speed flying out of the water bottle rocket. And after analyzing these, we can get this for later on. This is the final formula derivation. We can get that when the small amount changes in velocity will be related to the mass and also the pressure, like this, just like the pictures. This is an extension theory that will be used when I'm matching my results to this. So this is the theory from the previous page. After analyzing it, we can get this one. And this is going to be used later. After analyzing that one in the previous page, we can get that the acceleration is this. So I will explain this equation in the end of the presentation. Now is my experimental setup. So these are some items on about the rocket, and this is the most important part on this page. So this data will be I will use this data to simulate the flight of water rocket to get the ideal flight. These are the variables of this experiment. So first, it is the control variables. These are mainly about the water rocket, and then is the independent variables. These are what the problem statement states using it to check if it's accelerating. And for the changing quantity of the velocity, I'll use it to calculate the acceleration. These are the results of the first experiment. So in the first experiment, I fixed the water level to 0.1 liters in the bottom. So for this, you can see that it's accelerating while it's being released. And for this is when I change the independent variables from 1 bar of air pressure into 2 bar. So as you can see, the speed when reaching the same time is higher than the previous page. These are the results of the accelerating comparison. So for this, it is calculated from the velocity chart in the previous page. That is about 1 bar, and this is about 2 bar. So for, you can see that the highest peak of the acceleration is higher when they are in the when the acceleration is higher. But these are the simulated results for this. I used the experiment, the data I listed in experimental setup to monitor this, and so for the simulated result, you can see that when the pressure is getting higher, the highest velocity they can reach is also higher, but the time of the peak acceleration doesn't change much. And these are the results for 4, 5, 6 bar. It also only changes in the highest velocity, but when this is data analyzing. For you can see when I control the air pressure in 1 bar, you can see this. It looks like the simulated results for 1 bar, and this is the simulated results for 2 bar. So you can see the peak of the acceleration appearing in similar time. And this is experiment number 2. So for this, I fixed the air pressure, so only changing the water amount. I fixed it at 3 bar. So and then you can see this is an accelerating chart. And for this is for controlling it at 0.1 liters. The results can show that for this is 0.1 liters and this is 0.2. So you can see when the water is added, the peak of the acceleration will appear later on. So for this, it appeared at approximately 0.01 seconds, and this appeared after 0.01 seconds. So for the simulated results, we can see when the water is added, the peak of the acceleration will appear later. And for more water, the peak of acceleration will also appear later. This is data analyzing. So you can see when the peak of my data appears, it's approximately the same time of the acceleration simulated. This is the peak of the acceleration chart. And this is the chart for 0.1 liters, and it also appeared in the similar parts of the graph. So for this, you can see that when the peak of the chart appears, it is bit later than the previous chart. So for the conclusion, we can see that when controlled at pressure, so you can see when more water is added, the peak of the acceleration will be there, and when you are at a controlled amount of water, the higher pressure will generate higher acceleration. So in high pressure conditions, the water amount usually increases while the system can have a better acceleration. For this, it is more comparison on the peak of acceleration. So you can see it doesn't change much. And this is for the comparison of adding water into the system. So you can see when more water is added, the peak of acceleration will appear there. This is the theory I mentioned in previous page. So this is a demonstration of changing the pressure and about this equation. So as you can see, when the pressure is beginning to lower than a specific amount, the line will change from this to this, and this means that in lower pressure, when the greater the mass of the system is, the greater initial acceleration is. So this is the conclusion of the experiment. Thank you for listening.
Okay, this is the question about the opponent.
One question I want to ask that what's your definition of lift-off?
My definition of lift-off is
Was it that whole process that you launched the water rocket?
yes, but I only track the part of it accelerating. Because
Which process? Hit the highest point of
because the problem statement stated that is the accelerating of the liftoff. So my definition of liftoff is only a short length of.
extractions? Okay, that's okay. And because you use the water volume to be your manipulator variable, but I think that will also affect the weight and because the energy power down. Do you think that it will affect your experience data?
Yes.
Do you think that there will be a vertical volume in your data about the acceleration?
Can you say that?
When the water volume converted increase, and whether there will be some kind of the water bottom can enlarge.
Yes.
Okay, so can you turn to page 39? And also, I also want to know that how can you measure your air pressure inside your water bottle rocket?
I have a air pressure meter on the air pump.
Do you think that is accurate?
Yes.
Okay. Do you think that because you use the Bernoulli's formula to be your theory, so do you think that it will perfectly fix your experiment? Because I think that the water bottle rocket, the flow of the water, it will.
Time is up.
Okay, thank you.
Yes, 20 minutes for the version.
Girls Senior High School, and today I'm going to oppose the problem number 14, water bottle rocket. And here is the problem statement above. And we can know that my main focus about this problem is that how do the relevant parameter affect the acceleration and the flight trajectory, and how do the air pressure and the water volume change during the launch process. And here is the review of the report. About the presentation, we talk about the theoretical model, and he used the continued equation and the Bernoulli's equation and the conservation of the momentum. And I think that there is the lack of the force analysis about the propulsion process and didn't analyze the thrust. And I think the thrust that is the main reason that will affect the acceleration. And lack of the jet force, because that we launched the water bottle rocket, but there will be the air resistance, but he ignored it. And about the experiment and setup, he used the air pressure inside the water bottle rocket and the different water volume to be his manipulated variables. And I think he greatly measured the acceleration measurement during the launch process. But he didn't consider the difference of the air resistance in each situation because the velocity will be different. And I think that will affect the experiment data. And he didn't consider the shift in the center of the mass because he used the volume, the water volume to be his manipulated variable. I think that will affect the experiment data. And about the data analysis, he got the data about the velocity and the acceleration during the lift-off process. And he explained the data trend, but he didn't consider different water ejection velocity. And there is a lack of the critical balance because he used the water volume to be his manipulated variable, and lack of the aerobot, and lack of the connection with the theory. And about the discussion point, about the presentation, I want to discuss about the theoretical model. I want to discuss the conservation of the momentum and energy, and the change between the internal pressure and the water volume in the rocket body. I want to about the discussing point. I want to discuss is about does the air resistance significantly affect the acceleration change, and how does it affect them? And can you really ignore this error in your data? And about the experiment and setup, I want to discuss the stability control of the device and the measurement of the water ejection velocity and the acceleration measurement during the launch process. And I want to ask about the discussion point. I want to ask that, did you consider the impact of the weight when altering the water volume? Because that will also cause the energy and torque down, and that will affect your data. And did you consider the water ejection velocity and the shift in the center of the map as yes, because you use the water volume to be your manipulated variable, so the center of the map will be different. And did that really affect your data? And how do you calculate the change of the air pressures? And what is the data change? Can you connect with your theory? And about the data analysis, I want to discuss is the effect of the water volume and the launch and the acceleration. And I also want to discuss the trajectory and the variation of the internal pressure with time and volume inside the bottle. And I want to discuss the point is when changing the water volume, the weight will also change. And what point is the maximum velocity reached? And how does the acceleration change? And under what conditions will velocity reach its maximum volume? And here is all my presentation. Thank you. And I want to invite the report. And at first, I want to use your page that you show your acceleration data.
Which experiment?
Two. It's because I think that I can see the trend, but why? Can you tell me why the acceleration is not smoothized?
I think that like for this or this that is off the trend is because of my experiment errors and some other conditions like maybe
So what do you think that the reason that caused this error?
I think the reason that caused this error is because of the measurement errors. Like,
And did you consider the air resistance?
for air resistance, it is need to be this. So
Yes, but the air resistance will have a relation with the velocity. And when you have the higher velocity, well, the air resistance will be bigger.
yes, so I decided not to release the rocket with higher velocities to try to remove this from my experiment.
Okay, and can you turn to page 10? And I want to ask that what is the unit, because you use this chart but you don't have the unit.
So for the x-axis this is the mass of the rocket. For the water amount inside the rocket, and for this y it is the acceleration.
Okay, so can you extend the chain of this? Like I think that is your theory.
So when according to this equation, so when the pressure decreases at one point, it will reach another shape. So for this shape, when the mass is decreased, this is the mass and this is the acceleration. So when the mass decreases, the acceleration also decreases.
Okay, I got it. So can you use, because you put this theory here, so can you connect it with your data about the acceleration?
I also put that page on the end of my presentation to show that after looking at the results, we can see that when the water amount is smaller, the peak acceleration will appear faster, and also when the pressure is
Okay. So about your acceleration, do you think that why is the train will greatly decrease?
I think it's because of gravity and also because the air pressure inside and the water
So
decreases.
but during the long process, the water will gradually decrease.
Yes.
So I think that the gravity will gradually decrease. So why can you explain the decrease trend of this?
So in this experiment, I would think that the most important factor in this is the pressure. So when the water amount decreases, the thrust also decreases, because like with no water, there's no thrust pushing the rocket up. So when water amount decreases, so the gravity also decreases, but the pressure is also decreasing. So when as the theory in the previous page,
So you think that is because the gravity that's caused the detection?
I think it's the pressure that
Pressure?
is.
Okay, so because that you use the water volume to be your manipulator variable, and it will also affect the air volume inside the water bottle rocket. And but you also use the air pressure to be your manipulator variable. Do you think that will affect your data?
So you mean by this? Are you talking about this experiment or the next?
Because you use the water volume to be your manipulator variable, you consider the entry Kelvin down that will affect your acceleration.
So you mean when the water inside the water bottle is decreased, the energy will also decrease. So,
No, I mean that because you use the water volume to be your manipulator variable. When your water volume increases, it will also affect the weight of the water. So it will create the force torque down. And but your thirst and to cause the acceleration of our water bottle rocket, it will tone off. So do you think that
too heavy to eject. So after that point, I think maybe the graph will look like this. But that point is when
Okay, but I still think that it will be a critical value that because that you change the water volume and it will affect the thrust by the water and also affect the weight that will cause they will have an effect of the acceleration. And can you turn to the page that you use the when you use formula? Do you think that this formula can fix your experiment because that about the water injection, it will cause the water vortex. And do you think that that can be fixed? Do you think that this can perfectly fix your experiment?
because like this theory is talking about the
Yes, I didn't think that they will perfectly fix the experiment and they may be because that due to the theoretical curve by your that's okay. And I also want to because I think do agree with me that the thrust about inside of water volume and when we start the launch and the main reason that will affect the acceleration is about the thrust.
yes, I agree with that, but when we talking about thirst, so we need to consider also consider the amount of water and pressure. So I decided to put my main focus on these two.
Yes. Can you turn to your page acceleration?
Which
That's okay. Page. Your data and you show your acceleration. Because that I think that your acceleration is gradually it will have the decrease trend. But I think you say that the thrust is the main reason that will affect the acceleration. But I think that do you agree that the thrust can divide it into two parts? The first part is that the water ejected outside of water bottle, it will have the thrust. And the next part is that all water comes out of the water bottle, and there will be the air pressure inside, and it will also have the thrust. And do you think that this two parts will have this?
so you're saying that after all the water inside the bottle comes out, the pressure inside will also have thrust to push the bottle out.
Because you use the energy conservation in your theory, so I think that the thrust will not gradually decrease.
I think that it will mainly it will decrease is because when the water amount decreases inside the bottle, it is because the pressure inside push them out. So after there's no actual water inside the bottle, so it will only be the air pressure be having the thrust to push the.
So do you think that the thrust will gradually decrease?
Time is up.
Okay. And about the discussion, we talk about the acceleration check. And I think that's because he didn't make a robot and I can not see that the data can see anything. But I think that they will have the reason that because the third can divide it into two parts. And I think that there will also be a practical value because he used the water volume to be his manipulated variable. And but that will also affect the weight of the whole water bottle running and cause the force power down. And that will also affect the acceleration data. So and I think that he should also also consider the air resistance about his experiment. And that's all. Thank you.
Okay. Question of the reviewer. You have 3 minutes.
I want to ask the reporter. You know acceleration. You know the acceleration. Have you considered the mass velocity? Do you know? Because you know the max acceleration. Do you know the mass velocity?
I didn't consider
We didn't consider it. And the question for reporter and opponent. According to reporter, say water increase, then the acceleration will increase. Both of you agree with when the water is full of the bottle, the acceleration will be max. Both of you agree?
No.
No. Okay. And the question for opponent. You accept the reporter said the Bernoulli law this consider some condition. And what do you think? What condition can be considered in the Bernoulli law?
I think that the Bernoulli law cannot perfectly fix this experiment because of the water buoyance.
Water. Okay. And the question for reporter. What do you think? Question for opponent. Why do you think reporters' pressure detector not exact?
Can you repeat it again?
Why do you think the reporters? Why do you think reporters' pressure detector is not exact? You said you made him show his setup, and why do you think the pressure detector is not exact?
I just want to ask that what if that is accurate, and he said yes, and I agree with it.
So you have no reason, but
No, he measured
you
the
doubt
air
him.
pressure.
But you-
And his experiment setup can measure air pressure inside the water rock.
Okay, that's all.
Duration time. Okay, you go check your phone.
My name is Chen Xiangyong, and my name is Huan and I come from National Zhonghua Senior High School. I'm the reviewer for water bottle rocket. Next. Problem statement. Pump air into a plastic water bottle, particularly filled with water. Under certain conditions, the bottle is launched and filled into the air. Investigate how the acceleration during lift off depends on relevant parameters. Next. Reporter's course is a structural expression and a logical expression, the complete variable. What comes is geometry briefing and the experimental data isn't clear, not enough to know the result. And the left is the chart do not clearly explain the information. Next. Common for opponent. Pros is precise question about the one-layer data and greatly focus on the discussion with the reporter. The presentation can be finished within a limited time. But cons is doesn't assess the question more deeply. And the point of reporter. He didn't consider the solution when the water is spreading, it will spin or not. And also didn't show the theory and just calculate. And the image doesn't show the x-axis and the y-axis. Next. Discussion. I assimilate what parameter can I accept the opponent what parameter can be considered in the Henry law, and the opponent answer me is a lot of things. And the discussion 2 is according to this project is for the reporter and opponent. According to reporter, say water increase, the acceleration will increase. And I think delay agree with when the water fall off the bottle, the acceleration will reach the top. The both end no disagree. And that is all. Conclusion. Conclusion is, I think the reporter doesn't try the different shape of the bottle because according to the theory, the rocket bottle have the best shape, and that's all.
Okay, so it's time for question about operating now first.
So for my concluding remarks, I mainly talked about the expansion. So the opponent asked is there a limit of amount of water in water rocket? So I answered that if the amount of water is over a specific amount, the water rocket won't be able to go into it. So these are the questions opponent asked, and the main focus is this suitable for is Bernoulli's law suitable for this, and we had a conversation about it. So for removal, we had error bars, but maybe they didn't see. So about considering the air resistance, we try not to reach a high velocity to try to limit the differ in every experiment. And for that, I think that the pressure is the main factor. So it's answering to the trend decrease, and is Bernoulli's law suitable? So yes, the vortex can be ignored if focusing on a big amount of water instead of focusing on a small one. And for how to reach the max acceleration.
Okay,
So,
time is up. It's time for question order.
Again, I have some questions about the problem statement, particularly for the viewer. Does the problem state the how to measure the acceleration? Yes. Why did you ask the question about
measure of the velocity. I just want to know whether the reporter know the max velocity.
For the opponent, because I think the problem is asking during the lift arm. So what is the understanding about this lift arm? So it's not just flying into the air.
Yes.
So by a certain stage, I think you are asking the question about the flying into the air. Why is you have such kind of interpretation of the problem?
I think that the definition of the lift bar can be different. So I asked the reporter that what is his definition of the lift bar, and he said that for him is the lift bar is the process that a water bottle rocket max height. And
So that's your interpretation of lift arm. Okay.
yes.
Any other questions? Other questions? So I like this other questions because the real parameters, air pressure and volume. So from the equation of the reporter, do you think what is the key parameters? What do you think? From the equation of the reporter, what do you think?
I think that will affect the acceleration marks. The most is because the thirds, but it can have a relation between the water volume and the air pressure inside the bottle.
I agree with opponent.
In my theory, the main factors is the pressure and acceleration, but the thrust isn't considered inside. So I decided that to mainly focus on acceleration and pressure.
So now with the scoring time. Okay, so now the first one is 7, 6, 8, 6, and 6. The second one for 8, 7, 7, 7, and 7. Spiral for good. 5, 6, 5, 5, and 5. Okay, so please calculate the 10 minutes. This is